In this demo, we're going to take a look at the use of reference types. We have this demo divided up into two segments. The first one will focus strictly on just working with a simple reference type and how we can use it as a reference to a standard variable. And in the second section, we'll take a look at how we use references when we're passing variables into functions. So let's take a look at the first part of the demo where we're declaring a simple int variable called num and assigning it a value 3. So this is just common for what we've been doing for all of our demos so far in this class. And second, we create a reference type called refnum, and we assign the variable num to that reference type. Now, once again, we are overloading the use of an operator in C++, and in this case we're overloading the use of the ampersand. When we see it on this side of an equal or an assignment statement, this basically tells us that what we are referring to here now is a reference type as opposed to the address of operator, which we typically would find over here on the right hand side of the assignment operator. So all we're doing in this particular instance is we're creating a reference type, which will basically be an alias for an int data type, and we're assigning num to that. What we will do once we have that assignment complete is we will use a couple of output statements, and we will indicate what num contains, and then we will output the value for the variable num, and then we will also output the value contained in the variable refnum. Now those will be the same, and you'll see that in a moment when we execute the code. Then what we do is we increment refnum, so we're incrementing the reference type itself as opposed to num, and when we do the output statements we'll see that the value in num and refnum has been incremented the same. So basically we're impacting the same value. And just to prove that, we'll come down in the next statement here and we'll actually increment num by 1 and then output the two values here, and you'll be able to see that those as well indicate the same value after we've done the incrementing. And then finally we'll output the memory address of refnum and num so that we can see that they are equal, so they are pointing to the same identity or the same actual value in the memory location. And let's not be confused about the use of the ampersand here. This is the address of operator in this instance as opposed to the reference operator up here in this instance. So let's execute this code and see what the output looks like. So a control F5 so that our command window or our console window remains open. We've made changes, or I've made changes to the code since it's been built, so I will rebuild it again. And then we can see that our console window pops open. I will move it just to the side a bit so we can see the lines of code and how they pertain to the output. So our first output line says num contains, and it says the value 3, which is what we assigned up here. And then we also say refnum contains, and we see that it contains the value 3. We incremented refnum here, so now refnum should equal 4, and because refnum is an alias to num, it should also equal 4, and it does here in both of these statements. Incrementing num by 1 makes it 5, but also makes refnum 5, and we proved that with the two output statements. And then finally, when we output the memory address of the two, we see that refnum is located at 0018 FA98, and num is also located at that same memory address. This proves that refnum, the refnum type, is an alias for the type num, and that they both have the same identity. So let's close our console window for a moment. Now what we're going to do is go in and take a look at a more common use of the reference type, if you will. So in this case, what I want to do is I'm going to comment out these lines because I no longer require them for the time being. If you're using Visual Studio, there's a shortcut key combination that works very nicely for commenting out a section of code that you don't want to have execute if you're trying to do debugging, or in my case I'm demonstrating some other code and I don't want this code to execute and clutter out my screen. So the Control key, K, and C provides a comment shortcut, and it comments all of that code out for me. Equally well, because I have this code surrounded with the older C-style comments, I want to use this code, so I will simply highlight that and use the keyboard shortcut of Control K U, which means uncomment. So now this code has been uncommented. with the exception of one line. We'll take a look at, I'll change these in a moment because I want to demonstrate passing by value and passing by reference, and we'll do those in a moment. At the top of my screen, so for those of you who want to grab this code a little bit later on and paste it in or look at it in your own code editor, whatever it is that you might be using, I'm utilizing function prototypes up here at the top of my code file. Now typically you'll find these in header files, but rather than complicating the demo code here with multiple files, a header file and an implementation file, I've just simply included these function prototypes at the top up here for the time being, just so that C++ doesn't complain when I try to use the functions a little bit later on. So let's scroll down and take a look at what we're doing. The first thing I want to do is actually demonstrate the pass by value, which is the default mechanism for passing values to a function. And so what we're doing in this code is we have, again, our standard num variable declared of type int, and it contains a value 3. And then we're going to use some output statements to indicate in the console window which method or which function that we're actually in as the code executes, and then what the value of the variable is within that function as we execute the code. So what's going to take place when we execute this, when we start running the application, is that it will print out that we were in the main function, which we will be, because if we scroll up we'll be in the function main here. And so it says we're in main, and it will output the value of num, in which this case is going to be 3 because we haven't done anything with it yet. But then we will call the function pass by value, and we will pass in num as the variable coming into pass by value. Now here's our pass by value function, and you can see that it's accepting one integer type variable, and in this case I've used num1 just so that we don't confuse this variable num, which is the argument that's being passed into this parameter num1. I just have a tendency to do that in my code. I don't like to use the same variable names here in my parameter list as I do for the values that are being passed in. It's just my personal coding convention. So within the pass by value function, we will output this first line that indicates that we are actually in that function, and then we will print out what the value of num1 is, in which case we're going to use, as we see num1 here, the value that's passed in. That will be 3 because we are passing in the value 3 through the num variable up here in the function call. Once we've output the value 3, then what we're going to do is increment num1. Now the way that pretty much all programming languages work is that num1 has been declared within the scope of this function, so num1 is a local variable to this function, and when we make the change to num1 and output the value, you'll see that the value will become 4, but when this function call has finished, the instructions gets passed back up to where we left off, and we will print out one final statement that says we are back in main and the value of num is, and in this case we'll see that the value of num has been unchanged because this is a pass by value mechanism. So let's go ahead and run that code and we will see what that looks like. So Control F5 so that we'll keep the console window open. Yes to build the application, and then you can see as we take a look at what takes place here in our code, it says we are in main, the value of num is 3. We call pass by value, so we come down here and we output in pass by value. The value of num1 is 3, which is the value that we did indeed pass in here. And then we do the increment statement. Then we output what num1 is, which in this case it indicates num1 is now 4. Once that function concludes its execution, we step back into main, and then we print out we're back in main and that the value of num is 3. So this num1++ did not impact num at all. But what if we wanted it to? What if the whole purpose of our program was to actually make that change to the num variable, and we wanted that to be reflected and stored in the memory location? Well, what we have to do is we have to pass by reference rather than by value, and this is where that reference type comes into play. So what I've done here is I've just commented out the call to pass by value and uncommented the call for pass by ref. Now if we look at the function prototype a little more closely up here for pass by ref, we see that we are passing in an int type, but because we're utilizing this ampersand character, it says in the function prototype that it is expecting a reference type to be passed in. That's the purpose of the ampersand. Pass by value did not have that, so pass by value simply says I expect an int variable. That's all it's looking for. Pass by ref is looking for a reference type to a type of int. So when we come back down here and we see that we're going to call pass by ref and we're going to send num to it, here is our pass by ref implementation. So our data type of int, and here is the ref type, in this case num1, that we are passing in, but it will receive num as the argument. It will cast it to a ref type, or actually, when we take a look at it from this perspective, the num1 reference type becomes an alias for num. So it's not quite exactly the same as saying that we're passing num as a reference to this. We are actually declaring an alias to the num variable. So we will do the same thing once we're in this function. We will output that we were in the function. We will output what the value of num1 is as to what was passed in. We will modify it. We'll output what that value now is, and then come back into main and output the value again. In this case, num should change because we are passing by reference. So let's run the code and see what happens. Yes to build it. So again, similar outputs here. In main, the value of num is 3, which is what it should be in main. And when we pass, or we call in pass by ref, we are in that function, and the value of num1 is, and in this case we're saying num1, which is the reference type. We've passed in num to the function. We've created the reference type num1 to be an alias to it, which allows us to gain access to the value 3, which is what is existing inside num at this time. Increment it by 1 with the num plus or num1 plus plus statement. So we're not calling num plus plus, we're calling num1 plus plus. Num1 is now 4. That's what we output here, and then when we return to our main function, we see that we are back in main and the value of num is now 4. Again, the reason being is because we passed in num, it became referenced by num1, which is a reference type or an alias for it. Therefore, the num1 plus plus statement not only impacted num1, but it also impacted num because of the way that reference variable works, and therefore the output was 4. So that's a quick demo on references and how we would make use of them within functions.